Hi everybody, this is Eduardo Suarez. In this video we're going to continue with iRVision inspection and we're going to look at the histogram tool. The histogram tool measures the brightness of an image, so this tool can be used in a variety of applications where the evaluation implies using the brightness of the measurement area. Since we're measuring the brightness of the image, when performing an inspection you need to be extra careful about the layout of the camera and the lighting. You need to have a consistent lighting that is not going to affect the reading of the brightness of the part. A typical example would be if the ambient lighting changes with the time of the day, or if the part moves and the new position has a different illumination intensity. For this application, we're going to use the same images that we used in the previous video for AI error proofing. So we're going to use the same work cell, we're going to rename it, and we're going to change only the inspection vision processes. We're going to go to iRVision. We're going to select Vision Setup. We're going to use the same camera data that we had before on the previous video. And we're going to create a new vision process. We're going to select Create. And we're going to select Single View Inspection Vision Process. We're going to give it a name. As always, there are 1,000 ways to skin a cat, so I'm going to show you 2 different ways we can use this tool. We're going to go to Edit. We're going to select the parent tool, and we're going to set it up. For camera, we're going to use camera 1, and we're going to log any images. We're not going to make any changes to the snap tool, so we're going to select the parent tool, and we're going to add a new tool. We're going to go down the list to where it says Other, and we're going to select the Window Shift tool. We can either consider the part is not going to move, that always is going to be placed in the same position. In that case, we don't need to use this tool. Otherwise, if the part can move, we're going to need to use the Window Shift tool that's going to shift the measurement area of each one of the histogram tool that we're going to add later to the proper position during the execution of the image processing. Notice that the Window Shift tool automatically adds the GPM locator tool, and the input data type is going to be the child locator tool. We're going to select now the GPM locator tool, and we're going to use the same image that we have for pass. We're going to take a snap, and we're going to teach the reference position. We're going to move the control points to select the area that we want to inspect, and we're going to edit again the training mask the same way that we did before. We're going to take a snap and find, and we're able to find the part. Also, I'm going to add 3 more parts, and we're going to make sure that we're able to find all the parts. This is a part rotated that pass, and this would be the part that's going to be failed in 2 different positions. So we're going to save, and we're going to continue. We're going to select again the parent tool, and we're going to add this time a histogram tool. We're going to select again a part that we know that's going to pass. We're going to go back to the histogram tool, and we're going to set the measurement area. For that, we're going to select the area that we want to look for heat treatment. And we're going to press OK. So one more thing that we're going to do, we're going to train the mask. We're not going to consider the part that is black over here. So we're going to mask all this area. We're going to be looking only the part that is heat treated. Now we're going to set the range of interest, and we're going to go from 0 to 182. So 182 is an arbitrary value that I selected that I know that's going to give us a good evaluation result. We're going to pause in here for a moment and we're going to look at what the histogram is doing. We're going to click on the information bullet that we have in here. And what this is saying is that it specifies the brightness range of interest from 0 dark to 255 bright in range percentage. That's going to be the value that we're going to see here. In the result display area indicates the percentage of pixels within the specified brightness range. I'm going to show you in this illustration how this study works. The grayscale is going to go from 0, that represents black pixel, and it's going to go to 255, that's going to represent the black pixels or white pixels. So selecting the range is selecting on the grayscale the range of pixels that we're interested in measuring. So the result is going to be called in range, and it's going to be the percentage of pixels that fit in the selected range of the grayscale. So if we look at the picture on the top for the part that hasn't been heat treated, we can see that almost all the pixels are very bright. So the histogram is going to look like this, with almost 100% of the pixels on the right area of the scale representing a value of 255. On the other hand, for the part that has been heat treated, the histogram looks different. There is a distribution of pixels on all the range of the grayscale. We can see that there is a bigger percentage of dark pixels, and then in the middle range, the percentage decreases. So this is exactly where we're going to measure with the histogram tool. We're going to measure the percentage of dark pixels representative of heat treatment. We're going to go back to the histogram. We're going to select Fine. And you can see here that in range is giving us 75.2% of the pixels in the grayscale area from 0 to 182. You can also see here for each one of the grayscale numbers the number of pixels that it found. So you start from 0, that's completely black, couldn't find any pixels. As you keep going up, we start looking at this area of the histogram where we have a bigger percent of pixels. Then in the middle range, that will be over here, the number of pixels decreases again. And finally, it keeps continue until it gets to 255. We're going to select the parent tool again, and we're going to add 3 more histograms. Each one of the other histograms is going to be set up exactly the same, and they're going to be looking at the other 3 heat-treated areas. Finally, we're going to select the evaluation tool. We're going to select the variable tab, and for variables, we're going to look at the histograms. We're going to look at the histogram tool 1, tool 2, tool 3, and tool 4, and we're going to look for the percentage within range. We're going to go to the condition tab, and for condition 1, we're going to select variable 1, we're going to select variable 2, variable 3, and variable 4, and we're going to look that they are in range from 64 to 85%. We're ready to make a test. We're going to select the parent tool and we're going to select Snap and Find. You can see that in case for this part it passes and the in-range value is between 75 and 84%. We're going to take the next Snap and Find for the next part. This part is rotated and it failed. You can see here that in range is between 62 and 81%. 62 is below the 64% that we set as a condition. And this can be attributed to the fact that the lighting is not uniform. We can see which one failed. The one that failed was the first histogram. And you can see here that this area is brighter than the area that we have, for example, over here, where we have 81% of the pixels within range. So this is what I was talking during the introduction, that the histogram tool is dependent on the lighting that we're using for the inspecting the part. We're going to keep doing more tests. We're going to do another snap and find. And this part hasn't been treated, and obviously it's going to fail. The in-range value is going to be very low, although over here we have a very big value. That would be for number 4. That's going to be this one in here. You can see that the darker pictures, even they are not so dark in quantity, they are representing a bigger value than the one that we have, for example, on this area. So again, this is attributed to the fact that the lighting is not uniform. Finally, we're going to take the last snap and find. And for this part that is not heat treated and it has been rotated, the in-range value on the histogram number 1, it was only 33%. And on this one in here, we are almost on the limit, but inside the limit. So what we're going to do now, we're going to look for another way to do the vision inspection process. We're going to end this one, and we're going to create a new vision inspection process. We're going to go to Edit. For the single view inspection vision process, we're going to do exactly the same. And we're going to add another window shift tool. We're going to train the GPM locator tool exactly the same. We're going to select the parent tool again, and we're going to add another tool. This time we're going to add the bead inspection tool. The bead inspection tool is a tool used to inspect linear objects, such as, for example, when you are applying glue to the perimeter of a part. This tool is going to generate many consecutive inspection points equally spaced along the inspection line. And then the inspection is going to be customized based on the tool that is added as a child. In our case, we're going to inspect for brightness again. So we're going to use the histogram tool that was already added by default. So the first thing we're going to do, we're going to configure this tool. On the inspection line shape, we're going to select arc, and we're going to teach the points. So we're going to select the first point for the arc, and we're going to be looking at a point over here that is going to be directly above the heat treatment area for the teeth. We're going to press OK. We're going to select the next point, and we're going to move it to the mid position. And finally, we're going to select the last point of the arc, and we're going to go to the end of the line. So what we're doing here, we are selecting a line where we're going to be doing the inspection for the histogram, instead of looking at all the area around the heat-treated part. Once we have defined our arc, we're going to press finish. And now the inspection interval is going to be 10 pixels. So every 10 pixels, we're going to have a new point. Now we're going to select the histogram tool. We're going to set the measurement area. And for that, we're going to move the area to the first point that we have on the line. And we're going to select an area such like this. We can select fine, and here you're going to see all the points along the arc spaced every 10 pixels. And the one in blue is going to be the area that we're going to be looking for the histogram on each one of the points. We're going to set the range of interest. Again, it's going to be from 0 to 182. And if we take another fine, you're going to see now that we have all the points on 100% in range. That is quite different from the result that we had previously. We're going to continue with the configuration. Now we're going to select the evaluation tool. For variable, we're going to select histogram tool, and we're going to be looking for the same within range. Our condition is going to be variable number 1, and we're going to be looking for bigger than 95%. Finally, we're going to select the parent tool again, and we need to add 3 more bit inspection tool to cover each one of the other 3 heat-treated areas. Each one of the new bit inspection tool is going to be set exactly the same as the first one. We're going to select the parent tool again, and we're going to add another tool. This time we're going to add a count tool. The tool count is going to count the pass-fail number of all the inspection points. It's going to count the total number of items evaluated by the sibling inspection tools that appear before it on the preview. We're going to leave the default setting, and we're going to go to the evaluation tool. For variable number 1, we're going to select count tool 1, and we're going to select the number that failed. And in condition, we're going to select variable number 1, and we're going to be evaluating for variable number 1 equal to 0. That means that we don't have any failures. And we're going to save. Notice the layout of the tribune. There is a hierarchy where we're going to have the single view inspection vision process as a parent tool, with all the other tools as a children. Each one of the children tool is a parent tool for the child tool that is below it in a lower level. And then each one of the child tools is a sibling tool between each other. At the end, there is a sequence of execution of the tools from top to bottom, and the evaluation tool is the last tool that is going to be executed. We're ready to do another test. We're going to select the parent tool, and we're going to do an snap and find. Notice that in the case it passed, we have all the points that they are inside the range that we have selected that was bigger than 95%. We can select another snap and find for the next part. This one failed, and you can notice in here that the only point that failed is this one over here. We can look at this and find out why it failed. That would be on the bid inspection tool number 2. And we can look at the histogram, or we can do the evaluation tool. And it failed on this point in here with a value of 88.5%. So in our case, if we lower down a little more the threshold, if we go from 95% to 88%, we'll be able to pass. And also you can see that the heat treatment is not exactly the same as the heat treatment that we have on the other areas, where is taking a little more of the area, and here is very limited. So probably this will be a part that is going to fail anyway. Probably the coil for the heat treated was a little shift. We're going to take another snap and find. This is a part that we know that's going to fail. And it failed on 39 points. And finally, we're going to take the last snap and find for the other part that hasn't been heat treated and also is rotated. And you can see here that it failed on 23 points. Now we're going to make a small change. We're going to go to the histogram, and we're going to change the threshold from 182 to 150 on the range of interest, and we're going to see what happened now. We're going to take a new snap and find. For this one we passed. We're going to do another snap and find. For this one now we have 2 points where it failed. So this part probably we'll have to do a manual inspection. And next, the next 2 parts, the points that it failed is bigger than the point that we had before. So the idea is that you have to play with the values that you have on the histogram until you fine-tune it and you get a better result. Now we're going to go back to the work cell. We're going to open the teach pendant, and I'm going to show you the TP program for the inspection. The program is exactly the same that we saw before in the previous video. The only difference that in here on line number 4, where I'm executing the carry program, I'm going to be looking for variable number 1 on the evaluation tool instead of variable number 2. So that means that we're going to be looking for the count tool number 1 and number of fails. We can run the program. We can do a snap and find for the part that we passed. The number of fails is 0. So now if we run the program, we're going to run in step mode. The result of the inspection is 1. And the number of fails is 0. So for that, we're going to go to the label number 20, that's vision passed. Now we can run the part that we failed. We're going to take another snap and find. So we're going to run the program again. The result is 0. And now we're going to get the number of fails. It's going to be 55. And we're going to go to label number 10. In conclusion, I show you 2 different ways to use iRVision inspection. We look at the AI error proofing and the histogram, and we use the same part to do the inspection evaluation. Each method has its own advantages and disadvantages, The AI raw proofing is very simple to use. It relies on a learning process and requires really a minimum of programming experience to set up the tool. On the other hand, we use the histogram we saw on the first vision process, that the result wasn't very accurate or reliable due to the lighting conditions. On the second vision process, we were able to improve the evaluation, and we narrowed down the inspection to particular points in the target area. But at the end, we needed to fine-tune the histogram values to get a better result. Also, you might have noticed that for the histogram tool, the vision process setting was more complicated and requires a lot more vision programming experience. There are many tools available on iRVision that you can use for vision inspection. Based on your application, you need to find the tool that best fits your needs. But basically the process is as I show you in this video. I hope you find this video useful for your future vision inspection application, and thank you for watching.